most in the medical field, you are dealing with is optics. You use a lot of optics in your experiment, in your lab, in medical field. You're using another one, is called electronic instrument. The electronic instrument, in generally, is composed of two types. One is called DC, like your battery is DC. And another one is related with AC. AC is called alternating current. As you see, the voltage changes. Voltage changes versus time in the sine wave. DC, AC, the voltage basically is all come from the output here, output from the terminal there. So DC is a voltage, is a constant. Voltage is, as time go by, the voltage is keep a certain constant until like a battery, until it dies. Okay, it dies. So or deteriorate. AC, the voltage is oscillating like this. Basically, from our electrical output is in general is 110 volts. Now, when you go to China or Taiwan, they are using 210 volts. So in their cases, when you're using the electrical instrument, you have to be aware. So this is the way related to this. So the first thing we like to talk about in there is the electric current. Electric current. Something electric current. Current defined as I. In which cases is electrical current is I. The unit for this I is ampere. Is to honor the scientists who did a lot of work on that. So by definition, the current, define the current, it means the charge, electrical charge flow per coulomb per second. So basically current is delta Q divided by delta T. So as far as unit goes, is a coulomb per second. If we coulomb per second, we give a new name, in which case it's called ampere. So, or you can using another symbol for it, current equal to dQ dt. So now we have to look inside the electrical wire, the charge moving. After the charge moving, so picture the charge moving. This is the concept we present to you is our thinking is that goes around. But we will show you later on. So here is a wire to amplify this wire, magnify this wire bigger. So here is a segment of it, in which case the area A. And this is the charge moving is delta X. And assuming there's some velocity of the charges moving, in which cases with a velocity v sub d, in which cases is the current, the charge moving. So here I have a Q, the charge. So when it moves, the distance is v sub d times delta t. So that is the case continuity flow. In these cases, then delta Q is equal to N. N is defined as number of charges per unit volume. So you have a delta N times delta X times times the area A, that's volume. And that times the charges, Q. Each charge particle with certain charges. So in that case, that equal to N times A times V sub D times delta T times Q. So that is the basically that is the delta Q charges. So the current defined as delta Q divided by delta T, then this is equal to N, because delta T cancel. So N times A times V sub D times charge Q. So that define the current. So the things that we like you to be appear important to you. In this area going here, we have a current density, in which case this is called current density, is equal to density is Ej, is defined as current divided by area A. That is called current surface density, in which case is defined as equal to NQ divided by V sub D. Okay, so in these cases, we like you to be aware of this. So you're thinking about if there's some voltage across a wire, will push the charge moving. So so that you're thinking the charge move extremely fast. In which cases, give a lot of people misconception. This N sub D, V sub D is have an information called drift speed. Drift speed, the charge moving. This drift speed is extremely small, extremely small, in couple centimeters per second. So here is the idea. They might ask you for the MCAT. So now we're looking at these electrical things, electrical fluorescence lamps going. We turn the lights on. Turn the lights on. And now we turn it on. Ladies and gentlemen, when I turn the light off, just in a few microseconds, the light is gone. And we turn on a few microseconds, the power will lay on. So here is a major drama, conflict. V sub D is the drift speed of a charge moving in the wire. How come when I turn on and zap, the light's on? So that has certain explanation. So the charges in actuality when they're moving are very small, in a couple centimeters per second, or even less than that. That's a precisely, that's a numerical number on page 684 and 685. Please look for it. And anybody get that number and tell me that you get extra brownie bar. So that when this is going,